Hey kids, this is Mr. Little again. Hey, I'm going to go ahead and orally provide the Texas gateways over this unit. It doesn't have oral built into it, so therefore I'm going to go ahead and read it. If you just enjoy hearing it orally and you prefer it that way, then by all means use it. But this is really for my accommodated students that need that oral interpretation. So here we go. We're going to start with Earth rotation and revolution. Okay, it's got a kind of a pre-assessment built in, and we'll go through that. I'm not going to go through the answers because I want to see if you can get them right on your own. It says, let's see what you know about the solar system by taking this short quiz. 1. The center of the solar system is the A, Earth, or B, Sun. And then, of course, you'd select your answer and click Submit. Number 2, list the planets in order, starting from the planet that is closest to the Sun. A, Earth, Venus, Mars, Mercury, Jupiter, Saturn, Neptune, Uranus. B, Jupiter, Saturn, Venus, Mars, Neptune, Uranus, Mercury, and Earth. C, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. Or D, Mercury, Earth, Jupiter, Saturn, Uranus, Venus, Mars, and Neptune. You may remember me saying at some point during class that I had a mnemonic that I used when it came to listing the order of the planets in our solar system. You may remember me saying, my very educated mother just served us nachos. That may help you remember the order of the planets. So, number three, the inner planets are called the gas planets, or B, the terrestrial planets. Number 4, the blank separates the inner planets from the outer planets. Would it be A, asteroid belt, or B, the sun? So that concludes the pre-assessment, if you will. Next up, and I'm not going to play it, but you can do it on your own, is a video segment. How did you do? Let's review a few of the concepts from above by watching this short video. So if you need to watch the video and have a little more of a better background on our own solar system, by all means, please go ahead and access that video. Okay, next up is an interactive exercise. Let's see what you've learned. Pictured in the chart below are the 8 planets in order from their distance from the sun. Drag the name of the planet to its place in the chart below. So you would go ahead and select each of the planets here, and you would put them in the correct box. Next up is a section over Earth's rotation. The solar system is not simply a collection of stationary planets, moons, and other bodies around the sun. Each planet rotates or spins on its axis. The rotation of the Earth on its axis causes day and night. As the Earth rotates, only one half of the Earth faces the sun at any given time. The half facing the sun is light or day, and the half facing away from the sun is dark or night. The animation below shows the Earth's rotation. When viewed above the North Pole, the Earth rotates counterclockwise from west to east. This is also called a prograde rotation. Because of this direction of rotation, we see the sun rising every day in the east and setting in the west. If a planet spins in a clockwise direction, it is said to have a retrograde rotation. Venus is an example of a planet with a retrograde rotation. The Earth rotates on its axis once every 23 hours and 56 minutes. So does that mean that all places on Earth experience 12 hours of light and 12 hours of dark each day? If you think about it, you know that that is not true. During certain times of the year, we have more hours of daylight than at other times. Why is this? The answer is that the Earth's axis is not at a right angle with the sun. It is tilted slightly at an angle of 23.5 degrees. The diagram below shows how Earth's tilt is in relation to the sun. Because of the tilt of Earth's axis, the amount of daylight varies throughout the year. The least amount of variation occurs at the equator, while the most amount of variation occurs at the poles. Because of this wide variation, it's never completely dark at the poles in the summer, nor completely light in the winter. Now, interestingly enough, this next interactive exercise, neither myself or Miss Lovern could get this to show up on our page. So we're not going to go ahead and talk about it because neither you or I can see what is going on here. Nor can we answer the following question, again, because we cannot see the interactive animation. So we're going to continue on to Earth's revolution. In addition to rotating on its axis, the Earth also travels around the Sun in a path called an orbit. The motion around the Sun along its orbit is called a revolution. The amount of time it takes for a single trip around the Sun is called a period of revolution. The period for the Earth to revolve around the Sun is 365.24 days, or 1 year. The 0.24 days is why every 4 years, February has 29 days. Earth's orbit is not a perfect circle. Instead, Earth's orbit is slightly elliptical in shape. The animation below shows the Earth's revolution around the Sun. A common misconception many people have is that the seasons are caused by the distance of the Earth from the Sun. This is not true. Because Earth's orbit around the Sun is slightly elliptical, Earth is actually slightly closer to the Sun in the winter than it is in the summer. Remember that in section 2 of this lesson, we discussed that Earth's axis was tilted about 23.5 degrees. It's the tilt of Earth's axis that causes the seasons. The following diagram shows Earth's revolution during different times of the year. Pay close attention to the direction of the Earth's tilted axis. An imaginary line, the equator, runs horizontally around the center of the Earth, dividing the Earth into two hemispheres. The area above the equator is referred to as the northern hemisphere, while the area below the equator is called the southern hemisphere. Texas is in the northern hemisphere. During our summer, we have warmer temperatures and longer days because the northern hemisphere is tilted towards the Sun and receives more solar energy. However, the southern hemisphere has colder temperatures and shorter days because it's tilted away from the Sun. This would be the southern hemisphere's winter. When the northern hemisphere is tilted away from the Sun, we experience winter in Texas. The temperatures are lower and the days are shorter because we are receiving less solar energy. However, the southern hemisphere is tilted towards the Sun, causing higher temperatures and longer days. This would be the southern hemisphere's summer. So my question to you is, during what month does Australia have its summer? And of course, if you click on the link, you can check your answer there. This concludes the oral accommodation for the Texas Gateways unit over Earth's rotation and revolution.